to talk about this. And as you can all clearly see, it says flying fish IJ slide rule. Or does it? That's my first question. Right, let's just have a look at some views of the rule. This is what I consider to be the front side. At the bottom, it has log-log scales, but at the top, it has scales G, I, two I's in fact, one scale that does a reciprocal of x times 3, and two J scales, and then we have some standard ones, C, D, and 3 log-logs. On the back, we have what appear to be perfectly standard hyperbolic and trigonometrical scales. So I'm now going to forget about those because they're not particularly interesting. Coming back to the front side, there are some formulae written at the top left. H equals minus B over 3, K equals that, A equals that. And also at the right hand end, G equals that, and R equals the square root of the modulo of A, modulus of A. And a rather nice logo here. What there isn't is a flying fish logo, which left me to wonder if it actually is a flying fish. Fortunately, Jose Fabregas sent me a picture of the box that slide rule comes in, and there's flying fish clearly written on the top of the box, and this collection of Chinese characters here, which come from the rule, matching the collection of Chinese characters on the other side of the box. So I claim two conformances to the theme of this meeting. First of all, there's fish involved. And secondly, as far as I can tell, this says Shanghai. Shanghai means on the sea.
That's correct.
Duncan, who said that?
That's correct.
Oh, okay. So I claim an extra brownie point, as we say. Now these are the instructions. Very clear. I'd like to thank Bob Adams for sending them to me. I believe this also says Shanghai right here, in a slightly different font. Shanghai.
Shut.
Shanghai. Okay. Thank you. Now, I don't actually read that much Chinese, although as it happens, I can read some Japanese, which does help. And where it does help particularly is in the section headings here, because here we have the number 1 and the number 2, and 3, 4, 5, 6, 7, and so on. Section 8 is the interesting one because it covers the scales which are not normal for a slide rule: G, 2 I scales, 2 J scales, and a third scale, or 1/3 scale. And we'll come on to those when I've dismissed section 10 and 9. 9 explains how to use the trigonometrical and hyperbolic scales, and 10 refers to some scales which don't actually exist on the rule or any prints that I've seen. So I'm presuming that that section has been left in from some other version of some flying fish rule. S and V for calculating or kilowatts and horsepower, switching between kilowatts and horsepower. So, Bob Adams, thank you very much. Jorge Fabregas, thank you very much. Stephen Seal, who sent me some very good pictures, and he's not here present, because I happen to know there's only one American in this entire group, and she happens to be my wife. She's not here. So I know Mr. Seal isn't here. So, moving on, what do we have? Section 8, how to use the G, I, J, 1/3 scales. And it clearly states that it's for solving, for working with cubic equations. And it gives 3 examples of cubic equations which I'll work through as part of the instructions. And example number 4 is not actually an example, but it's solving of a quartic or biquadratic equation. Now the instructions for cubics are fairly well explained. You just have to, given that you've got x cubed plus bx squared plus cx plus d equals 0, then you just work your way through calculating various intermediate values, thank you very much, capital A, and so on. And you do that by using pretty much regular scales up to that point. Then you switch to using the I scales and the J scales to get G. So G is then, you have an intermediate value G, and then depending on the value of A, which you calculated earlier, you then have to follow 3 different routes through the instructions. I'm not going to go into this in huge detail because it's in the proceedings or on the USB stick. But you end up with eventually calculating some further intermediate values called I2 and I3, J2 and J3, having looked up J1 and Jm, or I1 and In on the slide rule. For certain values of an intermediate variable G, if it happens to be greater than 0.385, and I have no idea what the significance of 0.385 actually is, then you have a different special case and you have to follow a 4th path through the instruction. Eventually you end up calculating intermediate values x1, 2, and 3, and then you can use those for calculating the roots. Then you have the actual worked examples. One particular splendid formula is x cubed plus 1.71x squared minus 5x plus 345,070 as an example to work your way through. And this gives you, once again, you've had this magic value of G, which is greater than 0.385, so you have to do some different mathematics than if G had been less than 0.385. Now, trying to do all this on the rule, I found a little difficult. I don't have an example, I don't have a real rule, but I do have this handmade piece of wood, scales nailed to it, mock-up. Excuse me?
You made it yourself?
I made it myself. But it's just printing out the scans and nailing them to a piece of wood and then printing out a slide and having that loose. So I thought I need to use a computer here. So I just took half a dozen or so values from each of the scales, G compared with I1. You put them into a piece of software called Curve Expert. There are innumerable linear regression items of software you can find on the web, so you might find a better one. And that tells me that actually the formula relating G to I1, the relationship between the G scale and the I1 scale, is something like that. So it's an equation to the 5th power. And for the other possible scales, I have other similar formulae, which end up with formulae that look like this. So now I can write some software to do some actual mathematics to simulate the operation of that slide rule. And here is the software, Flying Fish IJ slide rule simulator. And then I started to just play with the worked examples and some other examples as well. In parallel, I found on a website called Wolfram Alpha, they have what they call a widget, which allows you to type in numbers, cubic equations. And although my results aren't exactly the same, I'm getting answers which are pretty close. And the fact that there are differences is probably just due to the fact that I didn't put enough points in when I was calculating the formulae for each of the scales. So that's done, and that's done. Now we move on to the quartics. So thus far, I've been repeating the talk I gave in Stratford last year, when I promised quartics for next year, that is to say this year, that is to say right now. So actually, once again, you just have a string of numbers to work your way through, a string of small formulae to work your way through. There are, at some point during the instructions, there is the possibility of taking one of 3 different routes. And the end product is a pair of quadratic equations. Now, quadratic equations we can all probably solve in our head because we were doing that in our secondary schools. So eventually you end up with 2 quadratic equations, which gives you 4 roots in total, which are the 4 roots you require for your quadratic equation. They give one worked example only, which is a little disappointing because the worked examples for the cubics did follow all the tracks through the instructions, through the list of formulae, whereas the quartics only gives the 1. I think that's probably because they realised they were onto a losing thread here, because no one was going to even try to use the slide rule for solving these equations. Once again, I found a piece of software to give me some answers, and once again I added the quartic solving mode, and once again I get roughly the same answers. I'd like to thank you for your attention. There is, thanks to the work of Andries de Man and Jorge Fabregas, I don't know if it's on the USB stick, but it's certainly online. There's an online simulator for that slide rule.
Interesting.
May I have a question?
Yes?
Is there another slide rule from another manufacturer that does make such equations to find? Or is this...
Not that I'm aware of.
No, I have never seen this. Therefore, before I'm going to find out how my Japanese and Chinese is, maybe there was another slide rule also have that.
Maybe.
Okay. But you have never seen?
I've never seen or heard of such a thing.
All right.
Jerry, thank you very much.
You're welcome.
Again, you